Good morning, teacher. My name is Emilio Caleb, and I am going to present our Proyecto Aula, Automated Classifier with Robotic Arm and Conveyor Belt for Accessible Educational Robotics.
The STEM Educational Challenge. The Practical Training Gap. Technical programs require intensive hands-on experience in robotics and automation. However, high cost limits schools from providing real industries infrastructure. Commercial barrier. Similar market kits range between $200 and $400, making them unaffordable for public schools. Theoretical gap: students are often restricted to paper-based concepts, leaving them behind in critical industries 4.0 skills. CAPES solution offers an affordable, modular, and open-source alternative easily replicated using if-then 3D printing.
The CAPES project is carried out throughout a collaborative framework structured into two specialized modules, which facilitate efficiency and organized project management. Teamwork has proven essential for overcoming challenges related to component adjustment and mechanical integration, resulting in steady technical progress due to the specialization of tasks and combined technical abilities of the team members.
I will explain the main objects of our project. First, the general goal is to develop an affordable education kit that combines a conveyor belt and robotic arm. This system is designed to classify different materials while providing a practical learning experience for high school and college students. Second, in the design and build stage, we focus on creating both the mechanical and electronic components of the kit. This includes the conveyor belt mechanisms, inductive and optical sensors, and 4 degrees of freedom robotic gripper that can detect and support objects. Finally, under control and pedagogy, we program the automation system using finite stage machines. In addition, we provide an interactive web platform that includes guides, STEM, project, and multimedia manual to support learning and make the educational experience more engaging. Overall, this project combines engineering, automation, and education into a single accessible linear platform.
To counter the natural anisotropy and fragility of 3D printed BLA, the 4 degree of freedom articulated arm design applies a strict safety factor under maximum horizontal bending stress. This factor is calculated to prevent mechanical failures when holding heavy metals components at maximum horizontal reach. The precision of the robotic gripper and the feedback loop correction of the joint servomotors are governed by the classical proportion integral derivative algorithm. The proportional action provides speed, the integral actions eliminate friction when steady state induced steady state overs, and derivative actions dampen mechanical overshoot.
Regulatory Compliancy NOM 001 SCFI 2018 Electronic Safety establishes strict requirements for open current protection in power adapters, preventing risk for electrical fires in classrooms. AIC 61101 Laboratory Equipment Safety regulate touch safe limits. The CAPES kit operate under 5 volts and 12 volts DC, classifying as safety extra low voltage to ensure student safety. ROS International Directive Restriction of Hazardous Substance guarantees all circuit board and solder lines are completely lead-free, allowing safe, long-term tactile student usage. And ASO 2768 Manufacturing Tolerance Medium M controllers dimensional tolerance and 3D printed likes and laser cut chassis to prevent mechanical jams or joint misalignments.
The system architecture. Mechanical and actuation module. The several instructor framework designed to support rods and rotated moments from power elements. Convoy visual. Acrylic liner platform with synchronous drive and bearing power via DC lead motor via an H-bridge. For build robotic arms, the structure remains founded in high-density PLA polymer actuated by 4 PWM controlled servo motors. The sensory and control module. The intelligent core can read environment inputs and process signals in real time. Infrared sensor TCR-T5000 tries on the process of detailing physical parts on a conveyor belt. The inductive sensor LJ1283 generates high frequency magnetic fields to differentiate mechanical parts from plastic. The microcontroller 18 Mega 328P executing and non-blocking within stream machine framework. Thank you for your attention.
The Asynchronous Digital Ecosystem is an interactive educational platform, a web platform designed to assist and structure hands-on laboratory lessons, bypassing school infrastructure limitations. PVC card security access, a safe login structure linked to physical PVC cards containing unique alphanumeric student credentials, 5 STEAM levels, guided labs guiding students progressive, from basic speed control to complex closed-loop sorting, integrated manuals, houses interactive guides, CAD files, electric schematics, and preventive maintenance checklist.